Good morning. My name is Hichol Kim. So it has been a long time that I have been to this kind of offline meeting in person. So thank you very much for giving me this opportunity. I'm going to talk about the present of modelless implant prosthetics. About 16 years ago, I started the digital dentistry, and I'm going to talk about my experience with modelless prosthetics. Many things are changing. The paradigm is shifting. The young people do not know about these. They see them in dramas. I don't think they take pictures with the films. And in the long time ago, actually, we took pictures with the film and developed them. Impression taking. In the 1990s, I learned that in school, and now many people use intraoral scanners. How widespread is the dental dentistry adoption? There's no accurate statistics. My intraoral scanner is the fifth one that I owned. So 1,000 units are distributed annually, and I believe 30% of the clinics already use the digital dentistry. About 5 years ago, we talked about how to share the dental dentistry, and about 200 people, implant prosthetics and other prosthetics, ortho treatments are approached in a modelless way with my colleagues. So 100 hours of training is done every quarter because we didn't learn it from universities. So we are sharing our experiences regarding the modelless approach. So we need to do the scanning. I believe ultimately we will go this way in the dental digital lab. When the impression is taken and sent to the lab, things will be made and sent to us. But in many cases, we are disappointed, and then we have to go back and forth between us and the lab to come up with a final outcome. So we have to have devices ourselves in our clinic to do modelless digital approach. That is the reality. And because of the efficiency, it is not reasonable to have all the devices in our clinic. And ultimately, the dental lab should cover all of these. So dental lab should be able to use the modelless approach. So I'm going to talk about the full modelless implant prosthetics workflow and causes of errors from a digital lab workflow. Full modelless implant prosthetics case review. First, we use the term full. Actually, we don't do modelless, but we say we use the modelless. So the title gets longer. We don't take impression, but we use the intraoral scanning, and scan post needs to be used for the impression copying. And we have a 3D scan data, and we do the CAD design. This is a technical stuff, and this is done in the existing labs, so this is something easy to tackle. And the milling machine, we can print out the final prosthesis. It's still in the research area, and there is some problem with the durability with the material, and no adaptation, no labor needs to be involved, and we need to deliver in an easier way to our patients. What is important in intraoral scanner? The scanner itself is important, but if you think the good scanners would solve all the problems. We can say impression would be taken very well if you use good materials. So training is necessary, and we are used to gypsum model, and we can catch the models made there, but we cannot catch the errors in the data model. So we look at the gypsum model carefully. So we have to look at the data very carefully. And the bite. So in the gypsum, it's different. It's hard, but there's a PDL in teeth. All scan data have holes, and how much holes there, we need to be able to identify whether that's correct in terms of errors. And the library, when impression is taken, impression copying or lab analogs are connected, and digitally we need to do the validation using the library. 3D data identical to real object is very important. On the left, implants, and everything should be merged accurately. I have skills because I have a lot of experience. 5 years ago, I thought a 5-micron error would be acceptable, but now the error rate is almost to zero. So the library and the scanned data need to be looked at. CAD software, designing with the CAD software, the lab technicians can use it. How to design the custom abutments, and how can we deliver that to patients conveniently? The 3 speakers talked about surgery, and without a guide, I cannot do implant surgeries. Without digital, I don't do implant prosthesis. That is the way to go. This is done by current lab technicians, but what we want is the authentic form of final prosthesis. The lab is making the interim prosthetics quickly, and adjustments need to be made later. And there has been a division of work between dentists and lab technicians. But now we are talking about modelless. We cannot do adaptation. And in the past, we divided the work between the dentists and lab technicians, but that needs to be changed. And we can see the measurements or figures, embracer size, ER type. Actually, I prefer cement type, but if you prefer to use ER type, you can make the CAD data simultaneously. And the virtual articulator, the potential interferences would be identified without actual articulator. Because of this, occlusal adjustment work is considerably reduced. And when we do the milling, in the past, the Osstem made the custom abutments, but in Korea, there is some legal issue associated with this. How to design the custom abutment? How can it be reproduced authentically in a modelless way? Custom abutments, that's very important in the cement type. Here on the right, the crown, this abutment is milled. That will determine whether modelless approach can be done easily or not. So if you look at the milling here, so this is one added last process. Usually 4-axis machine is used in a lab, so there's some limitations, and they can make a big difference. 3D printing. We use it quite a lot, and I've been using this full-fledgedly from 4 years ago. The replicas, this is not to check adaptation, but to use it as cementation jigs. We don't use a cement type because of the excess cement remaining, and we can limit that, but still you can be worried about that. Abutments are in the mouth, and using the replicas, cement crown bridge, so this can be inserted in there. And you can see very thin layer of remaining cement which can easily be removed. So the inside of crown can be replicated. And this can be done really easily in a digital approach. It is delivered. This is the secondary impression taking PFM. The margin is not good enough, and if you remove it, if it is ER type, you can see bonding material remaining. The X-ray needs to be evaluated, and if you remove it, you can see it is very clean. Milling of suprastructure. The original data and the output of milling are compared. 30 micron is the precision of the milling machines, but many parts cannot be milled, and you need to identify which parts cannot be milled, comparing original data and the scanned output. In the full mouth, the prosthesis should be within 50 micron, and there are proximal areas not sufficiently milled. And if you go deep, the milling cannot be done properly. We used to use a disc to remove it, but it can lead to fracture and reduce the strength of the material. But one of the things that we do is the single implant or 2-unit bridge. So this is what is prepared. Zirconia is not stained or colored, so glazing can make it beautiful. Abutments are anodized, and it doesn't require labor trimming, so it's right from the machine. Zirconia crown fitting can be the same depending on the setting. It depends on the machine, and we share information about this in our study group. So the prosthesis made virtually and the 3D printed replicas can be compared. Modelless way, this is made, and like fitting Lego blocks, this can be fitted, which can be enjoyed in terms of the work. So this is implant prosthetics. How can't digital lab do this? Based on our experience, if you're not careful, you have to go back and forth with the digital lab. So if you start the digital, you will realize this is very convenient, so you need to make a determination that you transition to digital. But digital cannot solve all the problems. Impression copying should be properly positioned. So scan post should be positioned properly, and X-ray should be taken. This is the basic. And you need to practice scanning. And you cannot get complacent if you bought the most expensive scanner. There is operator-dependent variation. So you have to really practice hard to do modelless. And scan post, the details of the post should be scanned. It's from impression copying. And in many cases, they make it without giving too much thought on the forms. So surface texture, library, and scan post shape need to be precise. In digital, after scan post is scanned, the scan post height and implant, the distance between them needs to be precisely matched, and the manufacturers need to make efforts in that direction. So, and some of these need to be done by a digital lab and cuff shape, so that we can deliver it to a patient without giving them pain. The superstructure design is better done by a lab technician, and they have time to work on details. But in abutment design, we do the surgery and we know the available situation, so we can get involved in the cuff design. So in more detailed way, whether it is for an aesthetic area or not. Superstructure design, this can be covered by the lab better. Whether this can fit very well without requiring a lot of labor. And abutment milling, the 5-axis milling machine. Superstructure milling. And we want to do a lot of things fast. We do about 10 crowns in a dental clinic, but they make about 30 in the digital lab, so they make some mistakes because they have to do high volume. If problem occurs, the quality would be as good as the lowest quality. Then people would be tempted to go back to analog, and we have gone through all that to reach this step. An interesting paper. The scanner is important, but the software versions need to be indicated. Trios is something I use, and it is changed to United. Depending on software version, the output would be different. So one of these is presented by a manufacturer and how to turn the machine on, and they teach us the software, but that's not good enough. When we graduated from a dental school, we are not an expert in impression taking. We have to practice. The same applies to digital. So 13 scanning methods have been tested. Arbitrary scanning is good. Korean people have a small mouth, so using retractor is difficult. But is this the best way? That was number 2. Precision is about in the middle, not bad. Depending on the scanner manufacturers and the software version, it can be different. M achieved the best result. G achieved the worst result using a model. But in the mouth, it could be difficult. G is not good, but one side is scanned inside outside first before going to the other side. On the model, the precision is within 10 micron. Very precise, like a model scanner. So the various surfaces can be scanned better and different angles, and intraoral scanners can scan better. So if I was surprised looking at the data in the first class, intraoral scanners are used for the scanning, and staff intraoral situation is scanned, and 100 micron deviations can occur, but it should be brought down to 50 micron to reliably use the scan. 100 micron deviation can be considered good, but still. Scan post scan, and there are many options in an analog way. Pickup or one-step, two-step, various options. And for scan post, there are options. Scan post, some scanners are good at scanning scan post, and others in scanning healing abutments. So we need to consider that. Scan post first, or and the software maker says to scan certain part first before going on to the next, but in reality, the other way around works better. And gingiva scan. When healing abutment is removed, the gingiva would be contracted immediately. So we need to think about the lapse of time after the removal. The gingiva can be contracted, and when prosthetics is delivered, the height of gingiva can be different. Next, scan alignment should be verified. And if there's a misfit, do we have to switch back to analog? There should be a solution for misfit in the digital world. We need to learn that. Scan post is very important. On the right, the irregular scanning, and that interferes with merging. So at the bottom, on the left, model scanner is used, and on the right, oral scanner is used. So Metascan scanner, actually they are being developed quite rapidly, so modelless works pretty well. On the right bottom, the error rate is 30 micron. If you look at the home at the back, that causes the error. 30 micron errors can be accumulated. Single is no problem. PDL and in the adjacent tooth and others can be used to accommodate the errors. So basically, improvement is needed if the errors can be accumulated. When error, we need to make a lot of efforts to develop parts so that we can reduce errors further to go for modelless abutment connection. Micro CT is taken, and we did the study on this, so we can see the entire thing. So this is the way to do research. The data is too big, and the computer is not working very well because of the huge data. The CAD data, our goal is to make the same data as CAD data. The cuff would interfere with the crown, and the top portion, more interference that occurs. So I sent it to some labs to manufacture them, and the labs make a pretty output and it looks good, but actually Osstem, the pre-milled rod, works very well, but Osstem products is pretty good. However, the CT is taken here. The connection portion works, but if the form above has errors, it can be a problem. 60 micron, up to 1 millimeter micron errors can occur. So we need to be able to control this to enjoy the modelless approach. So when abutments are connected, 100 micron or more deviations can occur. This is a small case, but in a big case, the deviation can get bigger. Superstructure milling, the contact, there's a misunderstanding. There's no undercut in the inside because of lockout, but there are many undercuts outside. How can we minimize that? On the right, the undercuts are minimized. The adjacent tooth can be trimmed to make it better, but some concavity can occur in the form of the prosthesis, so less milled on the left, and silicone milling machine is doing the work right now. The concave area is milled, requiring a lot of labor, work, and the time of milling machines. So this is the difference. So we get a lot of questions. We use the same design, and we usually have a 30 micron error rate in the design. And sometimes we do not know how to set the value. Is it to be 0 or minus 100? So these things need to be considered. If abutments, if superstructure doesn't fit, impression can be taken, but as I showed you, the custom abutments, if you process it, mill it at 90 degrees, the scan post can be used to solve the problem. The technique needs to be shared, how to make improvements. So clinical tips can be shared with each other. So digital lab, I don't think the manufacturer can recommend a certain digital lab, but in actuality, the scan post needs to be aligned very precisely, almost to 0 micron of deviation. Abutment milling, the modelless approach, whether we can reach that or not. In zirconia milling, we use the milling machine from the mill box. I don't think other companies can do this, and we use this mill box cam. And maybe Osstem modelless digital lab certification system can be established. And then the lab would make an effort to get certified so that we can enjoy the digital prosthetics in day-to-day activities. Let me show you a case. Occlusal perio problems are present. Digital wax-up is important. Full digital wax-up including occlusion. It's planned and the implants are placed. And on the day of surgery, there is some errors occur during surgery. We need to minimize the errors. Cement gap is 100 to 200. If you are lucky, it goes in, but sometimes it requires adjustment. After 3 months, we put things to merge on the gingiva and scan post. So these two would be merged using the T-shaped markers. This is originally designed wax-up data. As Dr. Kim said, facial skin data can be used or digital face bow system can be used. Final prosthesis is completed in a modelless way. So this doesn't go smoothly from the beginning. So you need to start from a single and ultimately reach the full mouth case, like connecting the Lego blocks so that you can enjoy the activity. Thank you for your attention.